This was the last thing we did, shielding effect. Saturday is a little messed up. There is one more batch before they just leave and you just enter. So you have to wait a bit. Hope everyone went through the notes for Gauss law. Let's see a question. Let's say we have this thing and we have a random cavity here. So here we have a charge Q1. We have a charge outside Q2. From here to here, the distance is d. This is a neutral conductor. This is the center of the conductor. And let this be Z. So distance between Q1, Q2 is d. Distance of Q2 from center is Z. Okay. So the question is, find force between Q1 and Q2. Find force between induced charge. Now see, when you keep a plus Q1 charge, what will happen? Remember last time we wrote, if you put a charge Q inside a cavity, what will happen? It will induce an equal and opposite charge. Induced charge on the cavity, induced charge on inner surface of cavity and Q2, induced charge on the outer surface of the sphere and Q2. This is a good one, that theoretical question. So of a sphere, and if you understood this, you'll understand the shielding effect pretty good. Let's get this. So we kept a charge Q2 outside and Q1 there. Will I be able to find this? Let's do this thing. So before that, let me ask you this thing. Draw the charge distribution. First, let's draw the charge distribution. B, C, and D. Let's say A is draw. First, show how will the charges look. For this system, how will the charges look? Approximately draw. Then find force between Q1, Q2. Then find the force due to the induced charge inside the cavity and Q2. Then outside charge and the Q2. Try. Just give it a try. I'll be back in a minute. Let's see. Force between Q1 Q2 0 near. Let me show you something. First thing, the charge distribution. Everyone, look. You have this cavity here. There are some problems here. Huh? First thing, this guy is Q1, so this will induce a minus charge, which is non-uniform, minus Q1. Agreed? This will be non-uniform because the shape is non-uniform. So if they ask you the question to find the force between these two, now we can't find. You're getting? We can't find force between these two. So between plus Q1 and minus Q1, you can't find because there's non-uniform distribution. But because of this plus Q1, what will happen? Outside you'll get a plus charge. This will be plus Q1, which will be uniform. Agreed? But abhi the question hua nahi. There's another problem here. This guy Q2 outside, this guy will create a problem now. If you put a charge outside a conductor, kya karega? This will induce its own charge, na? Minus Q. You're getting it? And this side will become a plus Q. So this will be non-uniform and we don't know the value. We don't know this. We can't calculate this. If you keep a charge outside a conductor, how much charge will induce, you can't find. You can find only if it's inside the cavity. So this Q2 guy will induce charges on the outer surface. Which is non-uniform. So outer surface will have two distributions, a uniform distribution and a non-uniform distribution. Overall, it becomes non-uniform. Makes sense? And we don't know this value. We can't find minus Q. Are you getting the distribution? The charge outside also will interfere. So that will create a charge on the outer surface. All got this? Now let's see the questions. So this is the first thing you should know. So what is the first question? Find the force between Q1, Q2. Do you remember force between two charges is what? Independent of every other charge. Force between this and this, why it should depend on this guy and this guy and this guy? This I taught you in Coulomb's law, remember? The force between them will be simply K, Q1, Q2, distance kitna tha? D square, straightforward, easy. What is the next one? This is a good one, right? Find force due to the induced charge on the cavity. Means I'm asking you force between this guy and this guy. How will you find that? You know what I'm asking? See. I'll just show you that diagram. I'm asking you to find the force due to this guy and this guy. We want the force between these two. Let me ask you something. When you have Q1 here inside, these field lines are getting stopped here. Does Q2 know Q1 exists? Q2 doesn't know that Q1 exists. Reason, Q2 does not know that Q1 exists since the field lines are zero, since there are no field lines outside. No lines from the cavity come outside. Why are they not coming outside? Who is blocking it? That means force on Q2 due to Q1 plus that induced charge minus Q1 is 0, right? Both of them together are cancelling out now. Is that making sense? This Q1 and minus Q1 together are not letting any field lines go outside. Is that making sense? Vrinda, is that making sense? Only Q1 is sending field lines, only minus Q2 is attracting, but together, if you take this together as one system, not a single field line will go till here, isn't it? In the previous question, you took only Q1 ka field lines will go. But if you take Q1 and minus Q1 together, you won't get any field lines. Therefore, force on Q2 will be force due to Q1, force due to minus Q1 is 0. That means force due to that induced charge will be how much? Minus of FQ1, which is minus of K Q1 Q2 by D square, no? The same as before, only the direction is different. Is that making sense? Think about it logically. This and this will repel. This and this will attract. But you're saying this guy doesn't know these things exist inside. Matlab kya ho gaya? These two must have got cancelled, no? Isn't that the only explanation? You're saying there are two people, one guy is attracting me and one guy is subtracting me, and I don't realize they're acting force on me. Means what? Both of them are cancelling out at every instant. Is that making sense? That means, indirectly what? You can replace this non-uniform charge with a Q1 charge in the center at that point. Is this logic clear, everyone? Sure? It's a good one. This is what I was saying. There are no numericals. You have to prove it by statements. Rishi? Make sense?
Sir, FQ1 was the force due to Q1 or force on Q1?
This is
same doubt. I'm not getting the FQ1 part. F of induced charge समझा.
This is F is Q1 and Q2, okay? This is F of minus Q1 and Q2.
Okay.
Fine. This should be 0, no? Got it? So this is basically force on Q2 due to that whole cavity, due to that complete whatever is that, due to Q1 and minus Q1. This is 0. So this guy is K Q1 Q2 by D square. So force between the minus Q1 and Q2 will be minus Q1 Q2 by D square.
So that is minus Q1 Q2 is only the induced force.
Induced force. This is the force due to the negative charge on the Q2. Clear with this? What is the fourth question? The force on the outer surface of the sphere. Abhi dekho na. What I'm asking you to find? This outer sphere is made of what? This outer sphere is actually made of two things, isn't it? The outer sphere is made of one uniform charge, which is Q1. The outer sphere of one more non-uniform. Minus Q and plus Q. Agreed? So if you want to find at this point here, you want to find you can actually split into two pieces. So you want to find the force at this point here, Q2. Force here due to Q2. So what will be the force between these two? This is like a uniform shell, right? What is the field outside a uniform shell? Acts like a point charge in the center. So due to this uniform force, uniform charge distribution, the force will be K Q1 Q2 by the distance square, distance from the center, which is Z. Is that clear? What about this thing? The force due to non-uniform? We can't find. We can't find. So there's no answer for this. We can't find this answer. Are you getting this? If you have a non-uniform distribution, the previous case was an exception. Huh? Even though it is non-uniform, because of shielding effect, you could find the answer. But if the non-uniform thing came on the outside, you couldn't do anything. I hope the logic was clear. You can find a part of an answer, but you can't find due to the non-uniform distribution. So the last part, you can't solve the question. Please check. Raina, clear with this?
Yes, sir.
Makes sense, no? Ritam, Divyanshu,
Yes, sir.
Hasni, Nishita, clear?
Yes, sir.
Right. Amu, clear, na? Great. Next thing. So this idea, right, that induced charge will affect is quite important. You can play more varieties. You can put, for example, if I ask you like this, there is a cavity here, there is a cavity. I can keep cavity also. If I say Q1 and if I say Q2, and if I ask you this question, right, there'll be charge here. What is the force between this thing and Q1? What will you say? The story is always same, na? Together, both of them will cancel everyone. So this charge will be equal to Q2 ka force, right, in the opposite direction. That is the main logic in these kind of questions. You treat that cavity plus that inside charge together as one system. They will not interact with anyone outside. Anyone, even this guy, they won't interact. Clear? All clear with this thing? Any doubts? Go ahead. Next one. Earthing. So what is earthing? It's like, when a conductor is connected to the Earth's surface, you must have heard this thing, right? Did you ever see a plucker point? There are 3 holes there. The top hole is called an earthing. You don't get any power from there. So when a conductor is connected to the Earth's surface, its potential becomes equal to the Earth. Be careful, huh? When you earth something, charge 0 nahi hoga. It can become 0, but that is not the condition. Its potential becomes equal to the Earth. And because Earth is so big, kq by r is so big, the potential of the Earth will not change. So what we do for convenience, right? Actually, Earth's potential is not 0. It is minus 0.1 volt or something. But for convenience, we take the potential of the Earth to be 0. Keep this in mind. Whenever you earth something, potential becomes 0. Charge kya hoga? We don't know. That we have to calculate, which we will see. So whenever you are earthing something, the symbol for the system is, this is the symbol for the earthing. So if I draw like this, means it is Earth. So the important points to remember when you earth something. First point, potential becomes 0. Second point, charge is not conserved. The charge can go into the Earth or the charge can come from the Earth. Charge is not conserved on a system which is earthed. Clear? Let's see some questions. We have 2 shells. Radius r and radius 2r. On this shell, you have a charge 2q. On this shell, you have a charge minus q. Okay. Find the charge distribution on each shell. Straightforward question. These are concentric conducting shells. And let's say there's a switch also between them. So find the charge distribution before and after closing the switch. Do you remember this question we did in electrostatics? The shells were outside ESA. Both were connected from outside. But this is a different scenario. You're keeping a shell inside a shell. Think for a minute, I'll show you. Then I'll give you one more model like this. This is a good one. Just to give an idea, think about it. Doesn't this look like a cavity? ऐसे सोचो ना. Suppose if you have a solid conductor, okay? Do you agree this is a cavity? Isn't that a cavity? If you have charge Q here inside a cavity, what happened to the opposite charge? Minus Q, na? So how does the charge distribution look like? Let me help you with one. I'll show you one, then you do the next one. So this is radius R. First thing, can you have charge here? Yes or no? Think about it. If you have charge inside, they can repel. If they repel, what will happen? They'll come to the outer surface, no? Staying outside is much better than staying on the inner surface. So whenever you give a charge Q to a cavity, this is case one, people. Last time we did. If you give a charge Q, what will happen? The charge will never enter the cavity, na? The charge will never enter the cavity. So when you give charge Q, all the charge will be on the outer surface. Inside will be zero. There will be no charge inside. How much is this? 2Q. Because this is 2Q, this will induce an opposite charge on the facing surface, which is also minus 2Q. Agreed? What is the total charge on outside? The total charge on outside is minus Q. So to conserve the total charge, the outside charge should become how much? Plus Q. Is this making sense, everyone? Because this total should be minus Q. Or if you're confused, I'll do one thing. Let this be X. So total charge on outer shell will be minus Q only, na? That is isolated. It is not connected to anyone. Total charge on outer shell will be X minus 2Q is minus Q. So X is equal to Q. Sure? So this is how the charge will distribute. 2Q minus 2Q and Q. Is that making sense? Can you just tell me what will be for this guy? Suppose if I have shell, 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 shell. Let's say I give you charges Q, minus 2Q, 3Q, 4Q. बताओ इसका distribution क्या होगा? The main idea is the opposite faces will have equivalent opposite, and the charge on each shell should be constant, conserved. Inside and outside should be constant, whatever is initial charge. Get this distribution once. What is the inside charge? Inside of the inner shell is how much? 0. Then what is the first shell ka charge outside? Plus Q. Agreed? How much will it induce on the opposite face?
Minus.
How much will it induce here? Minus q. If that is minus q, यहाँ पे total कितना था? Minus 2q. So what will be the balance?
Minus q.
Minus q, no? Are you sure what I'm doing? The inside and outside total should be minus 2q, no? Because you can't get any charge from outside, you can't get throw the charge anywhere. Now, if this is minus q, यहाँ पे कितना होगा?
Plus q.
Plus q, opposite charge. Total कितना था?
3q.
3q. But if you already have q inside, so balance is how much outside?
2q.
2q.
2q. Then this is minus
Minus
2q.
2q.
Outside is?
Plus 6q.
Please check. Is everyone getting the distribution what we did? Opposite will have equal and opposite. The total charge should be constant. So baki balance charge should be on the outside. You keep doing this. You keep doing this. No matter how many shells I give. Gauri, clear? Sure, no? Dipanshu, clear? Vrinda, clear? Kavya, Trisha, Arushi, all clear with us? Now, question abhi tak hua nahi. The question second part is now, what if I close the switch? All cells are conductors. Only for conductors charge distribute hoga Danya. If it is not conductor, na, charges won't move only, insulators. Though. All are conducting shells. Okay? Now, when you close the switch, what happens? Tell me one thing. If you connect two conductors with a switch, with a wire, what will happen? The potential becomes same. So what are the initial charges? 2q and minus 2q. No? So this is 2q and minus. Listen carefully how to do this. So the moment you close the switch, do you think inside will be 2q? We don't know, right? Some charge can go outside also. Let this be q. Okay? Then how much will this be? Minus q. And let the outside be x. Now, what is the total charge? Q, no? So when you connected the conductor, total charge will remain constant, right? Total charge cannot change. What is the total charge? X, no? Since charge is conserved, X should be equal to Q. Agreed? So we proved X is equal to Q. Itna tak aa gaya. But we still have to find small q, na? Abhi bhi small q have to find. Now, if you connect two conductors with a wire, what happens? The potential becomes same. Matlab at this point and this point, VA is equal to VB. Agreed? Since connected by a conductor. All clear with this? Please have a look at this. These are very important problems. These are very good ones. Shell wala problems. Divyanshu, clear na? Gauri? Clear? Danya, Anamai? Now, let me show it on the next page. So this is Q, this is minus Q, and this is Q. You're trying to find the potential at A and potential at B. Now, how many charges are there here? How many distributions are there? 1, 2, 3. Na? So when I ask you to find the potential at A, you should find at A due to all these three guys. So potential at A will be, now, this point A, is it inside or outside the shell? On the surface? Formula kya tha? Shell ka formula? K, Q by R. Agreed? Now for these two charges, where is the point A? Inside or outside? Inside. What is the potential inside a shell formula? K, Q minus Q by the radius of the shell. Na? This is due to inner shell ka potential. This is due to outer shell ka potential. Please check this one. The point A is on the surface for the inner shell. Point A is inside the outer shell. The total charge on the outer shell is Q minus Q. So it is K charge by radius of the outer shell. Is that clear? Next thing, point B is here. For the inner shell, where is B? Outside. For outer shell, where is B? Outside on the surface. So potential at B will be K Q by 2R plus K, the charge on the outer shell, by 2R. Since both are connected by the wire, VA is equal to VB. So you get KQ by R plus KQ minus Q by 2R is equal to KQ by 2R plus KQ minus Q by 2R. This will cancel. We get KQ by 2R is equal to 0, implies Q is equal to 0. Meaning, so whenever you connect like this, all the charge on the inner shell will come out. So this was Q. This was 2Q and this was minus Q. This is before the switch. Once you close the switch, this becomes 0, 0, and this will become Q. Got the final distribution? Please have a look at this.
Sir,
Shaurya.
Sir, if both the shells are not, means one shell is not inside the other, then potential due to the other one will be 0.
0, no? Then they'll not interfere. No? Remember that last question हमने जो electrostatics में किया था, they're very far. So we didn't bother this potential on this shell, this potential on this shell नहीं लिया था हमने. But here now it would matter.
एक शेल का जो पोटेंशियल लिया था वो एट द सरफेस लिया था ना KQ by R.
Yeah, surface.
Okay.
Everyone clear with this? Actually, this question, you could have done it in a much easier way, but this method is important because you won't be able to do the shortcut which I'm telling you now later on. Listen to this logic, okay? Suppose if there is a charge here and minus Q here, the field lines will go from where to where? Plus to minus, right? In the direction of the field, potential will decrease. But since you connected A and B with a wire, potential the same hoga. Meaning field should be 0. Meaning charge should be 0. Does it make sense? Again, listen to the logic. If you have plus Q and minus Q, then there will be field lines going from plus to minus. If there is a field line, the potential will change from here to here. But since you connected with them with a wire, the potential is same. That means there should be no field lines. That means there should be no charge inside. So small q is 0. Is that making sense? You could have just proved that by that statement. Small q is 0. No need to do all this. Got it? I'll just add it up here. If q is not 0, there will be field lines between R and 2R. And therefore potential should change. But we know VA is equal to VB. Clear? Everyone got the shell ka thing? Now let's try to do a problem. Let's see how we do. This will be a good one. Shell, shell, and we have a shell. 3 shells. Radius R, radius 2R, and radius 3R. The inner shell ka charge is Q, outer shell minus 2Q, and this is 3Q. You have a wire from here through a small hole. So there's a small hole, okay? You're not touching the second shell. So find the charge distribution after the switch is closed. So you're connecting shell 1 and shell 3. Shell 2 का contact नहीं है. Now there is no guarantee all the charge will come outside. Find charge distribution when switch is closed. Let's get this. This is kind of like previous one, but there are three shells, R2, R3, R, Q minus 2Q, 3Q. You're connecting the inner and the outer shell through a wire passing through the middle shell. You're not touching the middle shell. Means charge can flow between 1 and 3. 2 is isolated. Try. This is a good one. I'll give you 2 minutes. Just to give you an idea, right? Always start like this. Let this be small q because pata nahi na kitna charge gaya. Start from here. Small q minus q, remaining charge, remaining charge, remaining charge. Potential here and here are equal na. Abhi 1 and 3 ke equal karna padega. That is the idea. Charge distribution 1 and 3 are equal. From there you'll get small q ka value. Try. Please check the charge distribution whether you draw the same thing. So let the charges be small q minus q. The center ka charge is minus 2q. So this should be q minus 2q. Agreed? Because total should be minus 2q, everyone. If this is q minus 2q, this will be minus of q minus 2q. And outside let it be x. So charge on shell 1 plus 3 should be constant. Kitna tha wo? 4q. So from this, what is the charge on the inner shell? Q minus q minus 2q plus x should be 4q. QQ will cancel. 2q plus x is 4q. X is equal to 2q. Is this logic clear? Please check. Let
So
all
take x as capital Q plus small q.
capital Q plus small q. Q? Why will you take that?
No, because like jitna on the inner surface uska it induces the opposite.
ये किसने बोला ये statement, Trisha? When did I make this statement? When did I make this statement? यहाँ पे कितना charge है उसका opposite charge यहीं पे आएगा. Did you ever make a statement like that?
No.
What statement did I make? I said if you have a charge q here, inner surface में minus q induce होगा. बाहर कितना होगा मुझे idea नहीं है.
Oh, right.
अगर ऐसा है तो यहाँ पे क्यों ऐसा लिया तूने? You should take minus q, यहाँ पे plus q लेना चाहिए था ना? You're getting it? देखो ना यहाँ पे where did we take? See, this is plus q, this is 2q. Minus 2q, 6q. Charge conservation है ना? You can only make the statement for inner charge. After that, you have to conserve charge. Everyone, please ask this thing. Any confusion? Then you take this point A and take this point B. Potential at A is equal to potential at B. So first, due to the inertial, KQ by R, because A is on the surface. Due to the second shell, Q minus 2Q minus Q, total charge by 2R. Third shell, 2Q minus Q plus 2Q by 3R. This is the potential at A. KQ by 3R. Potential at B due to the inertial. K minus Q, 2Q minus Q by 3R, because the point is outside. K, 2Q minus Q plus 2Q by 3R. This and this will cancel off. Simplify this. K and R will cancel off. This will be Q. This will be minus Q. This will be Q by 3. This will be minus 2Q by 3. This will be 2Q by 3 is equal to Q by 3. Q is equal to Q by 2. Please check. Did everyone got the potential? This is the shell 1, shell 2, shell 3. You have to find the potential area due to all the 3 shells. How did you find the potential? K charge by radius. If the point is on the surface, KQ by radius. If the point is inside, then KQ by radius of the shell. Point B is outside for everyone. इसलिए देखो ना सबका 3R आया. Point A is inside for 2R and inside for 3R. So that's why we got 2R and 3R. Please check it. This thing should be clear. Any doubts on this? Please ask. All got this? Charge distribution and potential. We are just playing with these two. Any step you're not convinced, not clear? Anyone? Please ask. Go ahead. Gauri, clear, na? Ammu, got this? Tanya, Rinda, clear? Next one. Let's say we have a shell. We have a shell. We have a switch, and there's a grounding here. R and 2R. So someone gave a charge here, minus Q. Let's say someone gave you charge Q here and 3Q here. Now, if you close the switch, what will happen? Whenever you close the switch, what will happen? Potential becomes 0. Find the charge distribution when switch is closed. Remember 2 points we wrote. Whenever you ground something, उस shell में charge conserve नहीं होगा and the potential becomes 0.
Sir, could you repeat that statement? जो जिसको ground किया, उसको charge conserve नहीं है.
Yeah. And potential becomes 0. How do you do this thing? Try. I'll give you a minute out. first let's see whether you got the charge distribution right. Make sure to do all these problems again, right? Or else you'll forget all this thing. First thing, when you grounded the shell, is a charge conserved? So we don't know how much charge is there. Initially kitna tha? Q. Now how much is there? We don't know. Let this be X. That is the first thing. The moment you ground, you don't know what is the charge. Charge is not conserved, gone. If this is X, how much is this? Minus X. That is always valid. Huh? Kuch bhi ho jaye, that is always valid. The inner and outer should will be, the inner surface will have opposite charge. Outside kitna hona chahiye? Let that be some Y. Now, can I conserve charge on the outer shell? Outer shell is conserved, na? Outer shell is no problem. Outer shell kitna tha? 3Q. So Y minus X is 3Q. So Y is 3Q plus X. Is that making sense? Because outer shell is not grounded. Outer shell is isolated. Ho gaya? Now, what is the potential here? 0. Because it is grounded. बस हो गया ना, calculate the potential. So inner shell को होगा kx by r, outer shell को होगा k y minus x by 2r is 0. So this is x plus y minus x is 3q by 2 is 0. X is equal to minus 3q by 2. Done. Check. So that means your final answer is this. The moment you ground the inner shell, this guy will get a charge of negative 3q by 2. This guy will get 3q by 2. Outside you will get 3q by 2. This is a charge distribution. Outside total should be 3q. That we can never change. Trisha, देखा यहाँ पे, this is 3q by 2. This is also 3q by 2. Opposite नहीं आ रहे हैं. So you have to be careful. That comes from charge conservation. Everyone, please have a look at this. So whenever you're grounding something, this is how you do. That shell का charge conserve नहीं होगा. So you lost some information, but in return you got one more information. The potential on the inner shell is 0. Please check. Got this? How to handle this? Now, among the shells, the toughest one and the proper red, that if you understood the next question, I think you understood shells. Go to the next one. Any doubts on this page? Great. So if you can get this, you got everything. 3 shells. This is switch S1. This is switch S2. So I'm connecting 1 and 3 and I'm grounding the center shell. Sab ek saath. So this guy charges Q. This guy charges minus 2Q. This guy charges 3Q. Radiuses are R, 2R, 3R. Normally exam में what they'll do, they'll say I'll close S1, then I'll close S2. You can play around. So if S1, S2 both are closed, find the charge distributions. So you're connecting 1 and 3 and you're grounding the middle shell. You're doing everything. This will be an advanced matrix matching. S1 is closed, find charge distribution. S2 is closed, find charge distribution. S1, S2 is closed, find charge distribution. If S1 is closed, opened, and then S2 is closed, find charge distribution. So you can just play around like that. Let's close both of them and see. You closed both of them, find the charge distribution. Get it, you got 3 minutes. So whenever you connect 2 conductors, potential is same. Whenever you ground something, potential is 0. And charge is not conserved. Bas yahi concept tha. Everyone should try. Give it a try. Give it a try. Let's see whether you got the variables first right. Shell, shell, shell. You grounded this and you grounded this. First of all, what is the charge? Q1, I don't know how much charge will be there. That is also minus Q1 opposite charge. How much is the second shell? Is the charge conserved on the second shell? No. So Q2. We have two variables. So normally what we used to do now, we used to take this as Q1 and we used to say this is 2Q plus Q1, right? Because our total charge is minus 2Q. Isn't it? You could do that when it was not connected to ground because charge was conserved. Now that this is gone, we can't do that because we don't know Q2. Then this is minus Q2. Then this is X. All variables. So charge on shell 1 plus 3 is 4Q. Q plus 3Q, no? And here it will be shell 1 is Q1 minus Q2 plus X is 4Q. So X ka value will be 4Q minus Q1 plus Q2. There, I eliminated one variable. So I have two variables, Q1, Q2. Means you need two equations. Where will I get two equations from? A, C, and B. What is the potential at A? Potential at A is equal to potential at C, no? That is equation 1. What is the potential at A? K Q1 by R, K Q2 minus Q1 by 2R, K 4Q minus Q1 plus Q2 minus Q2 by 3R. That's the potential at A. This is equal to K Q1 by 3R, K Q2 minus Q1 by 3R. The outside point is always full actually. Everything is 3R only. Q1 plus Q2 minus Q2 by 3R. This guy will always cancel off. K and R will cancel off. You are stuck with Q1 plus Q2 minus 1 by 2, Q1 by 3, Q2 minus Q1 by 3. Equation 1. Agreed? What is the other equation you have? VB is 0. Isn't it? VB is 0. How much is that? K Q1 by 2R. B is outside for the inertial. K Q2 minus Q1 by 2R. K 4Q minus Q1 plus Q2 minus Q2 by 3R is 0. This is your equation 2. Please check 2 equations, 2 unknowns. Now we just need to simplify them and get the answer. Let me do it for you. This guy will be Q1 minus Q1 by 3, Q1 by 3. Actually, दोनों cancel हो जाएगा luckily. And this will be Q1 minus Q1 by 2, so Q1 by 2, and it goes that side, Q1 by 3, Q2 by 3. So perfect. First equation will be Q1 by 2 is equal to minus Q2 by 6. That's your first equation. That is 1 by 3 minus after minus 1 by 6 आएगा. Yeah. Q1 is minus Q2 by 3. That is equation 1. This guy will be Q2 will cancel. We are left with Q1 by 2. This guy also will cancel. You are left with Q2 by 2 plus 4Q minus Q1 by 3. You guys can simplify. So take that Q1 and dump it here. Q2 by 2, 4Q by 3 minus Q1 will be minus Q2 by 3 by 3. Numbers are bad. Q2 by 2 plus Q2 by 9 is minus 4Q by 3. 9 plus 1, 11. Q2 by 18 is minus 4Q by 3. 3 is up, 6 up. Q2 will be minus 24Q by 11. But anyways, if you got the equation, job is done right after this. Have a look at this. It's all math after this. Numbers are bad. So the main idea is shell 1 and shell 3 potentially same, and shell 2 potential is 0. This is how you do this thing. This is a proper advanced one, which has both connecting 1 and 3 and grounding the center shell. Everything is there in this.
How did you get KQ 1 by 2R?
KQ for which one? Mention properly. You just can't say KQ by 2R. What will I understand?
So VB is
one?
equal to 0 के नीचे वाला.
बोलो ना क्या हो गया problem? Where is B? Where is B?
Q B is there तो उसका radius
So
to
A के लिए where is B?
there 2R में.
2R. तो potential क्या होगा?
Oh अच्छा हाँ for A you are taking. हाँ.
ना, if the point is outside for the inner shell, it is KQ by 2R. All clear with this? This is for shells. Then we have parallel plates. So the parallel plates, right? This is the ending of Gauss law, and we are slowly entering into capacitors. So for this, the derivation is not important. The result is more important. Let's see that. Charge distribution on parallel plates. So if you have two parallel plates, close to each other, now if they give you something like this, so if someone gives you just two parallel plates like this, and someone gives you charge Q1 and charge Q2, the derivation is not important, result is more important. So let's see how to do that thing. So if you just give Q1, Q2 charges, I'm interested to see how will the charges distribute. So this is how the charge distribution is. The outside will be always Q1 plus Q2 by 2, total by 2. Outside will be Q1 plus Q2 by 2. This guy will be Q1 minus Q2 by 2. This will be opposite, will be Q1 minus Q2 by 2. So this valid is still valid here also. The facing plates will always have equal and opposite charge. So surfaces facing each other will have equal and opposite charge. Unlike shells, na, plates are quite little easy to solve if you know the basic results. Surfaces facing each other have equal and opposite charge. So let me give you a more general solution.
Sir, how it became that minus?
That's the result, Shaurya, you need to mark up.
Okay, sir.
Both can't be plus now. देखो ना, if you add this thing कितना आना चाहिए? Q2 ना?
हाँ.
If you add this thing कितना आना चाहिए? Q1.
Okay.
And by symmetry, if you see, right, outsides will look same. So remaining charge will be inside. What if you have n plates? Remember this result, right? Quite useful. Let's say Q1, Q2, Q3, Qn. The outside plates, the charge will be always the total sum by 2. Q1 plus Q2 plus so on till Qn by 2. Just add all the charges and divide by 2. This will be sigma Qi by 2. Now listen carefully, listen carefully. If you understood this thing, the parallel plate one part is over. The total is how much? Q1. How much is outside? This much. So how much should be inside? Q1 minus sigma Qi by 2. If this is the charge here, what will be the opposite charge? Negative of Q1 minus sigma Qi by 2. So if this total is Q2 and this side is this much, how much is this? Q2 minus this, the balance. You can just keep on putting like this. Let me take some numbers that will be easy to see. But this is the idea there. So the outermost plates will have a charge of total by 2. If you got this, your job's done. So let's say plate, plate, and plate. Let's say this charge is Q minus 2q and 3q. Can you tell me how much charge is here?
Plus Q.
Total by 2, na? Total will
Plus
be
Q.
q minus 2q, 3q. That will be 2q by 2. So plus q. So यहाँ पे कितना होना? यहाँ पे भी plus q. First put that plus q plus q. How much is here then?
0.
0 na? Because total should be q. The total q is outside. So 0 होगा यहाँ पे. If this is 0, how much is this? 0. Opposite faces will have equal and opposite charge. तो यहाँ पे कितना होना चाहिए?
-2.
And this will be 2q ना? And did you observe 2q plus 3q is 3q? Automatically आ जाएगा. Understood how the distribution? Let me give you one more example. Plate. Let's say this is q, this is minus 2q, this is 3q, this is q, and this is 4q. Now can you tell me the distribution? Outside is how much?
7Q by 2.
3Q, no? 6Q by 3, no? 6Q by 2.
No,
No?
yeah. 4, 4, 8, 2, 6, 3q, na?
6Q by 2.
Total by 2, right? Q total is 6q, na? 4, 5, 5, 3, 8, 8 plus 1, 9, 9 minus, नहीं रे, 7q by 2 only, right, Rishi? This is how
Sir,
much?
but Q minus 2Q and 3Q was Q, no? No, it was 2Q.
Oh,
Hey.
wait, minus 2q,
Sir,
na?
yes.
Wait.
Uh-huh.
Right,
It is
na?
7Q by 2. 7Q by 2.
7q by 2, हाँ. You're right, Rehan. So 7q by 2. Agreed? 7q by 2. Any doubts on this? तो यहाँ पे कितना होगा?
Minus 5Q by 2.
Minus 5q by 2, na? The total should be q. How much is this?
Plus 5Q by 2.
How much is this? हाँ रे ना? Getting there?
Minus 9Q by 2.
How much is this? 9q by 2. Then how much is this? So basically the
3Q
opposite
minus-
plate will be equal and opposite. उसके बाद चार्ज कैंसिल करना पड़ेगा. कितना था इस प्लेट में?
-3Q by 2.
Check the distributions.
So for a more generalized form, can we
Hmm.
say that the inner side of the plate will
Hmm.
have the charges up to that point on the plate, charges of the plates up to that point, and
इसके
then
लिए
minus
मतलब ये बोल रहे हो?
uh-huh. So say for the minus 2Q का plate का minus 9Q by 2 का charge,
But ये कैसे
that
पता चलेगा?
हाँ that
That we got this from here only ना?
हाँ
वो 9q by 2 आया यहाँ से. Got this? Understood how everyone how to do parallel plates? हाँ Rishi, clear ना? Now, if you take a parallel plate and let's say the charge is q and minus q, remember there'll be field lines in the middle. कितना होगा field? These are parallel plates, right? So basically you have a charge here plus sigma, which is q by area. This is minus sigma, which is minus sigma. This is. So basically you have two sheets here. a plus sheet, and you have a minus sheet here. So the negative sheet will generate a field of sigma by 2 epsilon. Remember field due to infinite sheet we did last class. So this will be sigma by 2 epsilon due to the red sheet. So the total field, right, between the plates field between the plates will be sigma by epsilon. Sigma is nothing but q by a epsilon. Q is the charge on any one surface. Charge on the positive surface of inner plate. Is this
Sir,
clear,
outer
everyone?
surface of the plates can have different charges.
हाँ वो अलग story है. But then it
But
really won't matter. Why? Because it's a conductor, na shielding effect. Field lines from outside won't come in between the plates.
अच्छा,
Getting it? Since plates are conductors, shielding effect. Outer field lines won't enter between the plates.
so means it will not notice which
Yeah.
adjustments will not be there.
So in parallel plates, there are three types. This is the first type which I showed you, direct distribution. The second type, right? You can listen to this model. I'll show you a general solution, then we can use this to solve problems. Like I'm saying again, if you know your results, it's quite easy to solve. Let's say I have 3 plates and you connected these two. Let this distance be d1. Let this distance be d2. Let this charge be q1. Let this charge be q2. So I mean this will be q1 and this will be minus q2. Opposite things. Agreed? So यहाँ पे field कितना होगा? E1, which is q1 by a epsilon. यहाँ पे field will be E2, which is q2 by a into epsilon. Agreed? Now, when you connect like this, plate 1, plate 2, plate 3, what is the relation between them? Plate 1 and 3 have same potential, right? So can I say like this V2 minus V1 is equal to V2 minus V3? Potential difference between 2 and 1 is equal to potential difference between 2 and 3. That means, what is the potential difference formula? Integral E dot dr, that is E1 dot dr, should be equal to minus integral E2 dot dr. E is constant anyway. So Q1 by A epsilon D1 should be equal to Q2 by A epsilon D2. So Q1 D1 is equal to Q2 D2. This is a very important result. If the distance between the plates is not same, and if you have a wire connecting them, this is the result which you have to use. The charge distribution will be in the ratio of opposite distances. Let me give an example. But is the logic clear?
Sir, how the first statement came V2 minus V1?
What?
So why first and third you told potential will be?
They are connected by wire. ऊपर नहीं देख रहे हैं क्या?
अच्छा ठीक है, मेरे को लगा ऐसे एरो बना है. Okay.
Arrow. 1 and 3 are connected by wire. God. Nishita, clear so far? Ramu, got this? Trisha, Reina. What happened, Reina? You're looking a little dull and tired. Now, let me give an example. Listen to this carefully. I'll give a similar question like this. So these two are connected. Let this be D and let this be 2D. So let's say iska charge hoga Q. Let's say this charge is 2Q and let's say this charge is 3Q. Minus 2Q. Okay. So first thing, let this charge be Q1 and let this charge be Q2. Agreed? 1. Before that, what is the outside charge? What is the outside charge? It is still valid. जो हमने starting किया था, that is still valid. What is the outside charge? Outside will be total by 2. How much is that? Q. Agreed? If this is Q1, this is minus Q1, this is Q2, this is minus Q2. And just now we proved Q1 into D is equal to Q2 into 2D. So Q1 is 2Q2. And we also know Q1 plus Q2 is minus 2Q. Substitute here. 3Q2 is minus 2Q. Q2 is minus 2Q by 3. Q1 is 4Q by 3. Done. So the first part we did is still valid. Outside will be total by 2. Beach mein assume this is Q1, Q2. Q1 into D1, Q2 into D2 should be equal, and Q1 plus Q2 should be minus 2Q. Please check. Got how to do? Ritam? Clear? Geet?
Yes.
Now, you try. I'll give you something like this.
But how is the charge only changing on the inner side?
The outsides are unaffected because see now, whatever happens here, these filaments will never come outside. The outer surfaces don't care. It's a social Harish, see, this Q1 and minus Q both will cancel out now. So this guy doesn't know what is happening inside.
Yes, the shielding effect will. No,
So,
but my thought was कि पूरे body को connect किया है ना. So
you're connecting the inner and outer, na?
no. I was thinking that wire said the whole bodies have been connected.
Diagram ऐसा नहीं है actually. Diagram कैसा है ना? These are very large plates.
So
And they're
the
very
so that
close,
face
actually.
has been connected.
Actually, ऐसा connect कर रहे हैं हम. These are like this. The gaps are very small and the plates are very large. What you're thinking is filaments यहाँ से ऐसा आ जाएगा.
No, not like that. I was thinking कि how is charge on only one side changing when the whole body has been connected by a wire to the other
Where
body?
it is one side changing.
As like only
दोनों
inner side. No,
Q1
on
Q2
like
दोनों
the
change हो रहे हैं.
वो minus
changing-
Q1 का.
Change हुआ ना, got all 4 changed. Outside surfaces
Okay,
will never
हाँ.
change. No? Find the charge distribution. Finish off. 15th is the last one. We still have to teach you what happens if you ground a parallel plates. That we'll do next class. I think today we did a lot of new things. Maybe make sure to sit and observe all this stuff by next class. They're not difficult, but they all are different. So you need to sit and actually do them again on your own. Don't read the notes, just do them again. If you don't do them on your own, you'll forget everything by Wednesday. Outside will be always total by 2. वो तो doubt ही नहीं है. हाँ Reena, outside will be how much?
So I thought it was 3Q by
Total by 2.
yeah, total by 2, 3Q by 2.
Right. तो बाहर होगा Q total by 2. 3Q by 2. 3Q by 2. This is always fine. Then let this be Q1, let this be Q2. Minus Q2 and minus Q1. Then from the equation Q1D is equal to Q2 3D, na? Easy. Q1 is equal to 3Q2. And Q1 plus Q2 is minus Q. हो गया ना? So Q1 will be how much? Minus Q by 3Q by 4. Q2 will be minus Q by 4. Easy. Please check. All sure with this? Geet, got it? Trisha, got it? Last one for the day. Four plates. Q minus 2Q, 3Q, 4Q. अभी क्या करेंगे? How much is outside? Total by 2. Discussion close. उसमें कुछ है ही नहीं. Total by 2. अभी inside कैसा करेंगे? Let's think about that. Try. I'll give you a minute or two. It's a good one. Pace में Gauss law खत्म हो गया ना? They taught you. Going on. After Gauss law, we will do viscosity and surface tension. So you'll have some time, finish off electro and everything. Then we'll go to capacitors. Gauss law is only like 20-22 questions, I guess. But I think first you should do class notes. You don't have these kind of models in HCB. How much is outside?
3Q.
3Q, yeah? 482, yeah, 3Q. 3Q. Now listen everyone carefully here. If I call this X, ये कितना होना चाहिए? X, na? Because this is D, this is also D, right? There's no need to take X and Y variables. देखो ना, if this is D, this is D. So this is X and this is X, na? X into D is equal to X into D. Agreed? If this is X, how much is this? Minus X. How much is this? Minus X. Let this be Y. तो ये कितना होना चाहिए? Minus X into D is equal to Y into 2D. So Y is minus X by 2, na? So this is minus X by 2. Then this is X by 2. Agreed? Please check this distribution. Now, if you take plate 1 plus 2, plate 1 plus 2 में चार्ज कितना था? 4Q. तो plate 1 plus 4 में चार्ज क्या था? 3Q minus X minus X minus X. This is the charges, na? That also should be 4Q because it is 1 and 3 is cancelled. So 3Q minus X minus X minus X by 2 is 4Q. So this is minus 5X by 2 is equal to Q. So X is equal to minus 2Q by 5. Please check. That result is very important. So see, what is that result telling you, right? It doesn't matter how many plates you have. This charge into this distance, this charge into this distance are equal product. You can do this for even 100 number of plates. So this charge into this distance, this charge into this distance are equal. Are you getting it? So you can keep on replicating that formula for multiple plates also. There are the two important concepts in parallel plates, three actually. One, outside is total by 2. Second, the inner faces will have equal and opposite charge. Third, Q1 D1 is equal to Q2 D2. There's a fourth one, grounding, we'll do in the next class.
So
Please
here we're
take-
talking
have a
about
look at
plate 1 and 3 now.
one. You could have taken plate 2 and 4 also. Same आएगा answer.
Okay, yeah, I was just confused because plate 1
You can
plus 2
see you
लिखा
have
था.
to take 1 plus 2 निकाल के. नहीं, wrong है वो. 1 plus 3 है my mistake. 1 plus 3 का. That's a mistake. You can take 1 plus 3 का conservation or 2 plus 4 का conservation. It works. All clear with this? So HCV, you can start working on it actually, because whatever is required for HCV level tak we are done. So, but I would say Wednesday tak keep a deadline. Gravitational electrostatics till Wednesday. Finish off that. Then you can start off with Gauss laws. Again, I'm telling you, don't chill out now. Exam is on 26th only for major.